Welcome. In this video, we will go over the concept of a passive house, the definition, the history, the key components, as well as the benefits of the passive house. So let's get started. What is a passive house? A passive house is a building standard that originated out of Germany in the 1990s. The passive house standard can yield energy savings of up to 90% compared to conventional homes. Not surprisingly, the passive house standard has expanded around the globe. Current estimates are around 60,000 homes around the world, including the United States. The history of the passive house. Dr. Wolfgang Weiss, a German physicist, and Dr. Bo Adamson, a Swedish scientist, collaborated to incorporate scientific design principles in home energy conservation. The first passive house was built in Darmstadt, Germany. Dr. Weiss went on to found the Passive House Institute, which is headquartered in Darmstadt, Germany. The elements of a passive house. There are several elements that, when combined properly, create a passive house. We will go through each variable. Insulation. A continuous envelope of super insulation surrounds the entire building, including the slab, the walls, and the roof. These levels are typically 2 times the amount required by code minimums. The purpose is to create a protective barrier between inside and outside temperature conditions. Airtight. It is important that the building does not leak cold or warm air between the outside and inside. This can happen through cracks and leaks, spaces between windows and walls, or through doors. Thermal bridging also needs to be addressed. Heat or cold can be bridged through screws, studs in the wall, or other weak points. Ventilation. With an airtight interior, a mechanical ventilation system needs to be installed to pump in fresh air and remove stale air. These systems are energy efficient and filter the air to extremely high standards. Furthermore, a built-in heat exchange system recycles the heat. Windows. Windows can be a weak point in the insulation. Triple-pane windows have 3 layers of glass with non-conducting gas such as argon gas in the middle of the panes. These high-efficiency windows make a significant difference. Passive solar and sun rays. As the sun's rays stream through the windows, it can heat the house if the windows are placed strategically. Thick floors or walls heated by the sun's rays can store the warmth and release it gradually to stabilize temperatures even after sunset. During blazing summers, it is important to shade the windows, which can be done by roof overhangs that prevent the direct rays from entering the windows. Orientation. The orientation of the building can be responsible for 30% or more of the building's heating through passive solar. By positioning the building in the right direction, the sun's path can be optimized to bring warmth in the winter and shield the windows in the summer. Conclusion. The passive house standard is an excellent method to create energy-efficient homes.
Now for a case study.
No solar, no geothermal, and no windmill apparatus in sight. So how can this house being built in a suburb of Washington be green?
Because the passive house focuses on reducing your energy demand to the absolute minimum.
David Peabody and his team at Peabody Architects designed the first passive house in the Washington area. Passive houses, he says, are virtually airtight, cutting the cost of heating and cooling by about 90%. But what really sets this home apart from other so-called green homes is the fact that it's so unremarkable.
That is the beauty of the passive house approach, is that you don't have to build in a particular way with any particular materials or to any particular style. That's why, in our case, we decided to try to do something that was, to prove that point, to make something that was very traditionally American.
Peabody Architects may have been the first to build a passive home in the Washington area, but they are certainly not the last. In nearby Arlington, Virginia, Roger Lynn and his brother Eric are in the midst of building a passive home.
You want to have a lot of insulation. As you can see here, this is a foam board. There's a 2-inch foam board. You can see it's basically a continuous insulated house all the way down to the foundation.
Even the windows are airtight when closed, surrounded by a special foam that prevents air from leaking past the seals.
And these are triple pane.
A nearby neighbor, Kathleen Harrison, says she is thrilled to see passive homes coming to her neighborhood.
I'm very excited that Passive House is coming here to the U.S. and that they're integrating a lot of things from what I know in Germany, because my family was in the construction business there.
The house is so airtight that on a crisp winter day with a temperature around 4 degrees Celsius, the temperature inside the house, even while still under construction, is a comfortable 12 degrees.
In here, we have, it's above 50 actually. It's above 50 right now.
Architect David Peabody says you can find passive homes all over the world.
North Africa, for example, has a passive house community designing for very hot, dry climates. And that's a whole nother area of exploration for passive house.
The first passive home was an apartment building in Darmstadt, Germany, built about 20 years ago with the help of 2 physicists, one of whom went on to found the Passive House Institute in Darmstadt.
They developed a methodology and they developed a energy modeling software that people like me can use who are not physicists.
Despite some of the specialized materials used in construction, like precast concrete panels, the ventilation system, or the prefabricated insulated board, the total cost of building a passive home is only about 5 to 8% higher than a traditionally built house. But a passive house uses only 10% as much energy as a conventional home, savings that can offset the initial investment relatively quickly. Rebecca Ward, VOA News.
Summary.
In 1991, a physicist in Austria, Dr. Feist, built the first passive house. Here's what he did. 1. Proper insulation. It's just like wearing the right winter jacket. It also doesn't need a heater. 2. No air leakages. There should be no holes, small or large, to let hot air out of the house. 3. No thermal bridges. A thermal bridge is like a road for heating energy in which warmth can travel right through your walls. As a matter of fact, most of our houses have thermal highways in our walls where heat can easily travel to the outside. Plus, the house needs proper windows most of the time with triple pane glass. It needs to be oriented properly so the sun can heat it in the winter and shade is provided in the summer. And it uses an HRV, a device that provides the inside with fresh air without letting the heat out. Add all these things up, and it turns out your house doesn't need a heater or air conditioner. So where does the heat come from? A passive house needs 90% less energy, and that can easily be supplied by your body heat, the sun, your appliances, light bulbs, and even your TV. This saves you a lot of money on your heating bill and helps preserve the environment.